School of Environmental Studies at Queen's University, and that's in Kingston, Ontario. And today I'm going to be talking a little bit about the impacts of waste transportation. You'll see several pictures. They're from a series I fondly call Garbage Run, where I got up at 5 in the morning and ran ahead of collection trucks and took pictures of people's garbage before it was picked up. Made some great friends, got some great runs in. And it's also from the Kingston Area Recycling Center, so those large bales of garbage you'll see is garbage that's processed in Kingston. So the transportation of waste is an essential component of waste management systems. Waste is a broad and varied topic, as we've seen this morning, but for the purpose of this paper, when I refer to municipal solid waste or just waste, I'm referring to those everyday items like coffee cups, apple cores, diapers, that are discarded and forgotten. So waste management could then be defined as the disposal, collection, and processing of waste materials, and the transportation of waste is its movement from its point of generation, households, industries, institutions, and so on, to its point of disposal, processing centers, landfills, waste to energy facilities, incinerators, dumps, and so on. So the transportation of waste requires substantial amounts of energy and a reliance on non-renewable fossil fuels. Excessive movement compounds the amounts of energy that is required to transport waste. For example, waste can be transported from its place of origin to a landfill in the same province, to a landfill in another province, to a landfill in another country, or to a landfill on another continent. So as waste moves further and further from its point of origin, its contribution to greenhouse gas emissions increases. So this geospatial movement of waste has significant environmental, social, political, and economic impacts. So a few fun facts about Canadians' waste. So Canadians, you can feel a little bit guilty, and all other nationalities can maybe feel a bit superior. Canada is the world's highest per capita municipal solid waste producer. So by 2005, Canada was generating 791 kilograms of municipal waste per person. This is well above the Organization for Economic Cooperation and Development's 17-country average of 610 kilograms per person, and almost twice as much as Japan. By 2006, Canadians produced over 1,000 kilograms of waste per person. So this translates into 35 million tons of waste in a single calendar year. The vast bulk of this waste, 27 million tons, ended up in landfills, and every province and territory in Canada has at least one landfill. In 2010, 30% of the existing Canadian landfills reached or surpassed capacities, which prompted municipalities across the country to explore other waste management options, like waste export, bioreactors, and so on. So waste-to-energy technologies are relatively new options in Canada, but Canadians tend toward more familiar management techniques of landfilling and, increasingly, waste export. Canadians export millions of tons of waste, much of it headed from southern Ontario and Quebec to Canada's north or to other countries, including the United States, Mexico, and China. With widespread landfill saturation, Canadian cities must find ways to manage its relentless and increasing production. So one way of thinking about the impacts of waste transportation is through engaging with the extensive risk literature. So according to Carrie Rowe, a leading landfill expert, the greatest risk posed by waste is not landfilling, but rather the transportation of waste considerable distances to landfill and dump sites. The public is increasingly being asked to deliberate on environmental issues for which the immediate, short, and long-term risks are inherently indeterminate. Engineers and scientists translate issues into a complex set of risks, including risks to environment, animal and human health, economics, and politics. In the case of waste transportation, risks like climate change from greenhouse gas emissions can have unpredictable effects which scientists are unable to define. The matter of public risk perception is not about the public's ability to understand technical information, but about the trust they are prepared to invest in scientific spokespersons or institutions. So risk is a set of ways of ordering reality that makes it calculable, and risk is a way of representing events so that they may be governable in particular ways. Beck defines risk as a systematic way of dealing with hazards and insecurity induced and introduced by modernization itself. According to Beck, Risk is a marker and an outcome of the success of modernity. In pre-modernity, risk, as we currently understand it, did not exist. In pre-modern societies, traditional institutions, communal structures like the church or extended families, shaped people's lives and gave people symbols that provided meaning, place, and purpose in society. In pre-modern society, the word risk had a note of bravery and adventure, not the threat of self-destruction of all life on Earth. In early modernity, the locus began to shift from structured forms of life as the provider of meaning to that of the individual as an agent who is loyal to structures and institutions. In late modernity, the newly emergent information society is reflective, agent-centered, and scientifically driven. For Beck, modernity is a world that introduces global risk parameters that previous societies have not had to endure. In a risk society, the unknown consequences become a dominant force in history. So, for example, Benjamin Hale and Lisa Dilling contrast oil spills and carbon emissions in terms of the indeterminacy of risk. Oil spills are a discrete and localized event that affects a specific region with identifiable actors that allows for an evaluation of harm, wrongdoing, responsibility, and appropriate remediation. Carbon emissions, by contrast, are an ongoing pollution whose effects are distributed globally, and whose suggested remediation, such as ocean fertilization, will have distributed and indeterminate global effects. As Canada moves waste from one region to another and to countries like Mexico, Korea, and China, where landfills may be open, unmined, and include unsorted waste, Canadian waste has a present and future global impact whose calculability is certainly indeterminate. This does not receive significant public scrutiny, despite the fact that the risk to public health and safety of transporting waste significant distances far outweighs the risk of appropriate local disposal in a fully engineered landfill. Not to mention the risk to the health and safety of the recipient community, who, from the recipient committee of less rigorous disposal regulations, and to the environment from the fossil fuel emissions during transportation. But because waste is relentlessly produced, what to do with this waste is an ongoing issue. So in addition to the risk and uncertainties that waste transportation poses, the movement of waste is also a way of divesting waste by putting it out of sight, out of mind. Harrington notes that the absent can have just as much as an effect upon relations as recognizable forms of presence can have. Social relations are performed not only around what is there, but sometimes also around the presence of what is not. But absence is only moved along and never fully gotten rid of. The transportation of waste is a way to move waste out of sight, but it is not a permanent solution to get rid of waste. Although waste is shipped, hauled, and freighted around the globe, waste is never gone. As Hurd et al. Explain, given the vast machinations of regulation, engineering, transportation, science, policy, governance, and behavioral rituals that are necessary to maintain our modern waste management system, it is remarkable that waste is, for the most part, so unremarkable. Put another way, the colossal waste management system is successful to the degree that waste is literally and figuratively out of sight, out of mind. So the practice of bagging, sorting, and putting the waste to the curb is an interesting phenomenon because at the curb's edge, the waste is no longer the responsibility of the consumer. It becomes the responsibility of the waste manager to take it away. The waste may end up in the same province, the same country, or a different country, but after the consumer has contributed their garbage, what happens to the waste is unknown or forgotten. So John Giles, the manager at the Kingston Area Recycling Center, said, "We need landfills. If you want to be sustainable, then put landfills near people because it means taking ownership." He joked that the middle of downtown Kingston would be a spectacular landfill site because it would force people to remember and to think about their waste beyond the curb. So you might have seen me walking around Memorial Campus, taking pictures, posing with litter, looking in people's garbage bins. It's gotten me a great reputation in Kingston. But I think what's interesting about being a waste researcher is that I see waste everywhere, and everything I see is waste or a breath away from becoming waste. And the waste that I'm constantly seeing goes so unseen by so many people for whom waste is just a common occurrence. So for me, waste is very political, but waste is not always understood as an issue. So another way, I put up a map. I'm not a geographer, I'm in environmental studies, but I put up a map to pander to my audience. So another way of thinking about impacts, and the aim of my research, is to identify and explore the waste transportation practices at Queen's University in Kingston, Ontario, which you can see located on the map. So through examining the diversity of waste transportation best practices and sustainable alternatives that are currently being employed by Queen's University in Canada and at universities internationally, in partnership with the Queen's Sustainability Office, I'm looking to develop a sustainability metric that measures the impact of transportation on university waste disposal practices using Scope 3 emissions. Metrics, or systems or standards of measurement, are used to measure sustainable initiatives and to assess an institution's progress towards sustainability. Metrics are critical to accomplishing sustainability goals insofar as they define system boundaries and the definition of improvement. The university's sustainable goals will not be successfully incorporated into action and initiatives until there are effective ways to measure progress towards them. The greenhouse gas inventory, the GHG inventory at Queen's University, is a total calculation of the GHG emissions and removals that occur within a specific area expressed in the term of CO2 equivalents. So CO2 equivalents are a universal unit of measurement that express the global warming potential of each of the 6 greenhouse gases listed in the Kyoto Protocol, including carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride. The results of the GHG inventory are often referred to as the carbon footprint of the institution. So the GHG inventory's operational boundary covers all Scope 1 emissions, as you can see, all direct emissions that are owned or controlled by the university, and Scope 2 emissions, all indirect emissions from the university's purchased energy. So Scope 1 emissions can include mobile combustion from fleet vehicles, fugitive emissions from lab chemicals and refrigerants, and stationary combustion from generators, kitchen equipment, and furnaces. Scope 2 emissions include the university's campus's electricity consumption and the electricity, cooling, and heating in all leased spaces on campus. Scope 3 emissions, all other indirect emissions, like employee travel, waste management contractors, and the supply chain, are not included in Queen's operational boundary. So the distances that waste management contractors travel to dispose of waste that originates on the university campus is not included in their greenhouse gas inventory. However, nearly all of the waste produced in Kingston, Ontario is transported outside of the city. This includes campus waste. Only organic waste is transported locally at a processing facility 40 kilometers west of the city. In 2010, Kingston's landfill site reached capacity and was closed to the public. Therefore, contractors like Waste Management Incorporated and BFI Incorporated are responsible for transporting 100% of the city's non-divertible municipal solid waste to northern Canada and the United States, formerly Michigan and currently New York. So Kingston's electronic waste like televisions, iPods, and computers is shipped to places like Mexico or India, where it is stripped for resources like its copper cables or its gold from printed circuit boards. The Kingston Area Recycling Center collects low-value materials like styrofoam and ships it in containers from Kingston to China several times a year. So at Queen's University, Scope 3 emissions are a relatively large source of emissions because of the third-party waste management practices of transporting waste away from Kingston. The incorporation of Scope 3 emissions enables contractors and companies to understand their full value chain emissions and to focus their effort on the greatest GHG reduction opportunities. If Queen's University were made to include Scope 3 emissions, they would have to consider where and the ways in which their waste is being moved by third-party contractors. So waste transportation has a variety of impacts that are simultaneously long-term and short-term, known and unknown, measurable and immeasurable, and tangible and abstract. So I hope to continue unpacking the nuances, the messes, and the paradoxes of waste transportation, and even more hopefully, this will culminate in a viable dissertation. So I'd like to thank my supervisor, Meyer Hurd, my committee members, Aaron Ball and Dr. Carrie Rowe, the session organizer, Josh Leposki, and Queen's University for funding I received to attend the conference. Thank you.
Great. We certainly have time for